Okay, I wanted to make a quick video going through a problem asking for a probability of a certain event, like B, given the fact that you know the probability of A or B is 0.6, the probability of A is 0.3, and the probability of A and B is 0.25. So this can be a little confusing, but the key thing that you want to keep in mind is your formula, which was that the probability of A or B was equal to the probability of A plus, remember that or is plus, the probability of B minus the probability of both of them, A and B. Okay, so once you agree on that formula, then you can simply plug in what we have. Now you can go through a proof of that by doing a Venn diagram, for example. A or B, for example, if you had a nice Venn diagram, if here is A and here is B, the probability that you're in A or B would be everything in A, including this little sliver, but it would also include everything in B, so that'd be all this, including this little sliver. But do you notice what we've done? We've taken everything in A, that blue part, we've taken everything in B, that red part, but the part that's in both of them, the overlap, we've actually counted twice. We double counted, and that's why we have to subtract the extra time that we've counted. So that's where that formula comes from. Okay, so now that we understand where it comes from, let's apply it. So we plug in simply what we know. I'll try to color code this for you. We're told that the probability of A or B is known to be 0.06. So I'm going to replace this part with 0.6 or 0.60 because I notice there's more than one decimal place here, so I'll make it easier on myself. Okay, we're also told that the probability of A is known to be 0.03. So let's take that probability. Probability of A is 0.03. So I'm going to replace that with 0.3 or 0.30, same thing. Now we don't know what the probability of B is. That's what we're looking for. So the probability of B, that's the unknown. We don't know what that is. So I'm going to keep that the way it is. You can write X, you can write a question mark, or you can just copy it. I'm going to copy it, the probability of B. We don't know what that is yet. And then what we do know is that the probability of A and B together is 0.25. So we're subtracting 0.25 according to the formula. So now it's just simply a matter of plugging in what we have and using basic algebra principles to isolate what we don't have. So I notice here what I don't have is probability of B, and that's on the right side of my equation. So basic algebra would say first step would be to combine like terms. So let's do that. Let's combine like terms here on the right side. 0.30 minus 0.25. Well, that's like 30 minus 25, which is usually 5. But with the decimal, it'd be 0.5. So we'll end up with 0.5 or 0.50 when we combine those two. And then we have still plus the probability of B on the right. Okay, equaling what was known to be the probability of A or B, which was 0.6 or 0.60. Next step in basic algebra, when you're finding an unknown in an equation, in a linear equation like this, is to isolate the term you're looking for. So in order to do that, in order to isolate the probability of B on the right, in order to do that, we need to undo the operation that's currently uniting it to this number, which is addition. So to do that, I would be subtracting 0.50 or 0.5 from both sides. And when I do that, I'll just have the probability of B by itself. And what will that equal? Well, we can see here that 0.6 minus 0.5 is just 0.1. As our probability of B. So let's just go through our check here. If you're given that the probability of A or B is 0.6, we plug that in. It should equal the probability of A, which is 0.3, plus the probability of B, which we don't know, minus the probability of A and B, which we do know is 0.25. When we combine these two terms, oh, I see I made a little mistake. Did you see what I made? I was wondering what happened here because it didn't seem right. I could always know I'm right, by the way, by checking my answer. But right here, I made a little typo. You might have already caught me. 0.3 minus 0.25. Be very careful there. Those are 0.05, not 0.50. I apologize. Arithmetic fail. Okay, you can see that if you line them up probably a little easier. 0.30 minus 0.25 does in fact give you 0.05. Okay, so that is 0.05. That was a mistake here. So let's fix that so that we get the correct answer here. I apologize. Sorry to make things more confusing. So it's 0.05, so we'll be subtracting 0.05 on both sides. Now that should give us our correct answer. Here, borrow here, 10 minus 5 is 5. 5 minus 0 is 5, so that's 0.55. Okay, so the probability of B should be this answer. Now the way I can check and know that I'm right is I can simply plug that back in to the original. And let's see, if I take 0.30 plus 0.55, that would be 0.85, minus 0.25, that is 0.6. We're right, so I can know that I'm right. So once again, in order to get this question right, we first needed to recognize the relationship between these three things that we're talking about. Probability of A or B, the probability of A, the probability of A and B, they're all related to each other in the formula. So that was key. Once you know that, you had to plug in what you know and solve for what you don't know. I hope that made sense, and if you have any more questions, feel free to email me. Happy practicing, because remember, math is not a spectator sport. I'll see you next time.